Questions can be asked. This is solvable within 3-4 minutes. we can solve it. Don't go for just what method you can bring it. Shall we go for chart distribution? Okay, let's see that. Let's focus on chart distribution. Q1 minus Q1, Q2 minus Q2, then Q3 minus Q3, Q4. Okay, this one. Shall I put charge QA minus QA, QB, Q minus QB, QB and minus QB, and no charge flows here. There's a really good problem where students are made to learn how to distribute charges. I'll assume this one. If you say I agree, then I'll write loop equation, then we'll get answer. Actually, we should learn first what? The capacitors. Then we should come to resistors. That's actually the scientific order. I don't know. In India, we are changed that order itself. Because see, once students learn the flow of charge, no, then the meaning of resistors branch current will be very easier. So since when you learn KVL, node analysis, come here and apply, no, the charge distribution method, you will not be strong. Anyway, like already we manipulated so many things. Okay, let's adjust ourselves. Is it okay now? Charge of SL, how much of charge will leave here? QA plus QB, QA plus QB, fine. Okay, we'll write loop equation. Okay, anyway, these two are series, these two are series. Will agree? This is wrong. Sir, where is it wrong? Everything is fine. See, everything is fine. Conservation of charge, sir. How much of charge? QA plus QB. QA plus QB is entered. What about here? This battery also does work, no? But sir, like I distributed charge, this is what happens here. So we are not very sure like what will be the charge in these two will be same, need not. If you remove this cell, okay, fine. So if this cell were not there, okay, no, correct. There's no problem. Huh? Getting the idea? Because of cell present, it should not happen. Getting the idea? So this will be the wrong. So what shall we do now? Okay, we'll go for chart distribution. It's a nice problem for learning purpose. Q1 minus Q1. Okay, this will be Q2, we'll take it. This will be, okay, we'll write Q3 minus Q3, Q4 minus Q4. Okay, how many unknowns are there? 4 unknowns. What about the isolated junction? So the charge of these 4 plates must be conserved. Look at this one now. What was the earlier charge of these 4 plates? Look at, sir, but there is a cell is also there. Let it be no problem. What to do with cell? Net charge of cell should be 0. Cell, let it be wherever how much of charge enters positive terminal, that much of charge should leave negative terminal. So let's not bother about that cell. Okay, there'll be exchange. So here, charge of this yellow color plates must be conserved. What was the earlier charge? 0, because initially no charge across capacitors. Okay, I'll take out this one. No, charge of yellow color plates must be conserved. No. What was earlier charge? 0 plus 0 plus 0 plus 0 equal to minus Q1 minus Q2 minus Q3 minus Q4. So therefore Q1 plus Q2 plus Q3 plus Q4 equal to 0. Right loop equation, 22 volt. Loop equation, sir. No. 22 minus q2 by 8 minus q3 by 10 equal to 0. Then 22 minus q1 by 3 minus q4 by 4 equal to 0. One more, we can also do like this: q1 by 3 minus q2 by 8 plus 6 equals 0. So what is this? The path like this. Huh? Q plus, if I move from negative to positive, plus rise in drop, plus q1 by 3 minus q2 by 8 plus 6 equal to 0. This is a path. So one more. Okay, we'll write here. Plus 6 minus q4 by 4. I think so many questions are there. Solving will get the required answer. I have Q1 24 coulombs. I have only some data is there. And VAB and VAB is 8 volt. Check it once. You do later on, calculations, everything. I think you should not take risk of fighting charge distribution. So why can't these two be same charge? So you can't say. That's why you solve this question. Definitely you are going to get all these 4 charges are different. So this shows that there is some charge distribution. You have to be very careful. On our own, we can't assume straight away like okay. Some problem is there. Wait. This will be plus. Please do notice actually.